we are going to apply trigonometry to non-right angled triangles, in particular using the sine rule and the cosine rule. The sine rule first of all. Now, as we said, we're looking at non-right angled triangles, so this is a rule that works for any triangle as long as we've been given enough information. The sine rule deals with using the angle and the side opposite the angle as a ratio, in that ratio for each side in the triangle to its opposite angle is equal for each of the vertices in the triangle. So this gives us a sine rule of A over sine A equals B over sine B, which is equal to C over sine C. This is a ratio of the side to the sine of the opposite angle. So the side is our lower case letter A, so that where our vertex A is, opposite that we'll have A for the side, lowercase a for the side, and for B, opposite that we'll have B, and C, opposite that we'll have C. So that's how we label our triangle. That is what this rule relates to in terms of the letters, and it doesn't need to be A, B or C. It could be P, Q, R, X, Y, Z, as long as we have this opposite rule in place. So it's always the side opposite to the angle, the sine of the angle, and in order to use the sine rule we need to have 3 bits of information, and one of those needs to be that we have a complete opposite pair. So we need to have a side and its opposite angle in place. And then we can either work out a missing side or a missing angle. We're going to look first of all at working out a missing side, and then we'll go on to a missing angle. Okay, so if we look at this example, we have a triangle ABC, and we have various bits of information in this triangle. We are told that we have from A to B is 10 meters. We have an angle at A of 41 degrees, an angle at C at 34 degrees, and we want to find this opposite side A. Now, just a point to know, in a triangle, remember that all triangles add up to 180 degrees. So in this case, we don't need to know this angle at B, but the fact that we have 2 angles in that triangle means that we can very quickly work out the third angle there if we needed to. However, in this case, let's set down our corresponding sides and angles first of all. So A, vertex A, we're at an angle of 41 degrees. Opposite that is the side A that we need to find. And then we have C, the angle at C is 34 degrees, and opposite that we know that we have the 10 meters as the side opposite 34 degrees, and for B we don't need to know that, so there's no need to work it out. So if we set up our sine rule, now we only ever use 2 of these in working out a missing bit of information and using this rule. So we're going to rule one of them out, and it will be B, and the side opposite B, we don't need to know that. So we can put our information in there. So A over sine A is going to be A over sine 41 degrees is equal to C, which is 10 meters, because the side opposite the angle at C is lowercase c, which is 10 over sine 34. And then it's a case of rearranging so that we have A equals, now we've got A over sine 41, so that's divided by sine 41. So when we bring that over to the other side, it will be multiply by sine 41 degrees. So the only thing that's changed here is this sine 41 degrees is moved across to the other side, and it's gone from the bottom of this fraction up to the top. In other words, we've multiplied both sides by sine 41, but very quick, we can do this in a very quick way of just the opposite. It's divide by sine 41 on this side, so when we take over, it multiplies. And then we can use our calculators. And ideally you'll have a calculator that's got a fraction button in there that you can put this whole thing into. So on the top you'll have 10 times sine 41, and on the bottom sine 34. Okay, and that gives us an answer of 11.74, and it's meters. It's the side that we're looking for, and the units are in meters, so you should put those units in there. We have another one here. This time it's C, D and E as our vertices of this triangle, so our opposite sides. Always useful to just a little sketch of the triangle, put in the information that you have. So opposite the vertex at E, we have lowercase e as the side, and C, we have lowercase c as the side, which is our 10 meters. And we can see right away we have a complete pair there, 10 opposite our angle at 37 matches up, and we need to work out D here. So we don't need to have E. So it's we can do this as a bit of a tick exercise. So we don't need E, we can cross that out, and these are the bits of information that we're going to use. So we can set that up, and I'd always set it up so that the bit with the missing bit of information is on our left hand side. Okay, so D over sine 133 is equal to our 10 for our C over sine 37 degrees. And then again, it's the same thing. Again, we've got sine 133 degrees on the bottom. On this left hand side, we only want D here. We want to know what D equals. So it's on the bottom here, and we bring it across to the top on the other side, or multiply each side by sine 133 degrees, whichever way you've been taught to rearrange. So rearranging, D is equal to 10 times sine 133 degrees over sine 37, which is equal to 12.15 meters. Okay, so that's using the sine rule to find a missing side. We've got one little thing that we need to do when we're finding a missing angle. So let's have a look at an example where we need to find a missing angle. We want to find the angle at A in this example here in this triangle. So we have various bits of information. It's an ABC triangle. We know one angle, 23 degrees, so we would need to know two of the angles to just use our triangle property of 180 degrees to work out another angle. In this case, we have two sides and one angle, and one of the sides is opposite the angle that we've been given, so that tells us that it's the sine rule that we can use here. So we can put in our corresponding sides and angles. So A is 45 meters, that's our side A, and then we've got our 38 meters opposite our 23, so that's our C, and lowercase c is 38 meters. So we have these bits of information. We don't need B, don't need to worry about that, we can just disregard that. Now again, it's the angle A that we need to find, so that's going to be our left hand side. So A is 45 meters, or lowercase a, over sine A, and that's equal to 38 over sine 23. Okay, so remember the angle is always the sine of the angle, so sine of A and sine of 23, and the sides are 38 and 45. Now this is where there's a slight difference here, because we can't just rearrange this. What we want to find is on the bottom of this fraction. So a very quick way of rearranging this, first of all, is to just flip everything round on both sides. So 45 over sine A becomes sine A over 45, and if we do that to one side, it's still the same on the other side, so sine 23 over 38, so we just flip the other side also. And what that means is now we have our unknown, our A, at the top here, and our 45 at the bottom, and we can just bring this 45 over and up on the other side. So we get sine A degrees is equal to 45 times sine 23, so that 45 is divided on this side, so we come across and multiply, so it moves from the bottom up to the top. Everything else is the same. We've got that times sine 23 on the top over 38 on the bottom, and we can put that exactly as it is into the calculator, and we should get a value that is less than 1. Okay, so in this case 0.463. I would always advise going to at least 3 decimal places here. Ideally you don't even want, you could do your dot dot dot, you don't necessarily want to be rounding at this point in time, because if you leave that value in the calculator, now this is the sine of the angle, this isn't the angle. So what we need to do to get the angle is the inverse sine or shift sine on your calculator. So shift sine 0.463 to find A, which is 27.6 degrees. Now just make sure your calculator is set in degrees mode, not in gradient or radian mode, as this will give you an incorrect answer and you may well lose marks for that. Okay, so using the sine rule again, here's another example in XYZ, and although you are given your sine rule on your formula sheet, it'll always be A over sine A equals B over sine B equals C over sine C. If you have a triangle that's XYZ, it's very straightforward just to substitute that as X over sine X is equal to Y over sine Y is equal to Z over sine Z, or whatever the letters you've been given. So in this case, matching up our corresponding sides and angles. Okay, so we've got 38 meters. Opposite that is X, and that's the angle that we have been asked to find. And then we've got Y, and opposite that, lowercase y, is our 75 meters. So we're going to put those into our formulae. We don't need Z, so we can just disregard that. So 38 over sine X is equal to 75 over sine 143. And again, what we want to find here is on the bottom of this formula. So what we're going to do is flip everything round on both sides. We can do that because it's two fractions. So flipping these round, we get x sine x over 38 is equal to sine 143 over 75. And then it's a case of 38 is on the bottom on the left hand side, so we need to bring that across to the top. So we get 38 times sine 143 all over 75. That gives us a value of 0.305. And again, that is the sine of the angle, not the angle. So to get the angle, we have to do shift sine or inverse sine of 0.305, and that gives us an angle of 17.8 degrees. The cosine rule is another rule, another trig rule for using non-right angled triangles. And we can use the cosine rule again in two ways to find the length of a missing side or a missing angle. And it's different bits of information in the triangle that we have in order to use the cosine rule. So it's about being able to distinguish between when to use the cosine rule and when to use the sine rule. But we're looking at them individually at the moment. So cosine rule to find the length of a missing side. Now, again, this formula is given. You do not have to remember this, but you do need to know how to apply it. And again, it's given in terms of A, B and C, an ABC triangle. I wouldn't recommend changing it to X, Y, Z. There's another way that you can really use this formula and use the ABC quite straightforwardly. So our ABC, remember, labeling our triangle, we've got our capital A, so lowercase a, side A is always the lowercase, and the capitals are always the angle. B opposite and C opposite the angle at C, and that's where we get our values for our formula. Okay, so let's look at this as an example. Now, the important thing is here, whereas the sine rule, we will have an opposite pair in situ. We'll have an angle and its opposite side as two of the values. This is not the case for the cosine rule. So we cannot use the sine rule in this case because we do not have an opposite pair. We have two sides and we have the angle between them. And that is where the cosine rule comes in. Okay, so we want to find this unknown side L here. Now, the hint I would use here in terms of, one, you recognise it's a cosine rule. This does not have labels on this triangle, so I would put labels, and for the cosine rule, whatever the angle is that you're using, that is A. Okay, the angle, A for angle. Okay, so if there's an A here, so 43 degrees is A, which means the side L is lowercase a. That's what we're looking to find. And B and C are interchangeable. It doesn't matter if 5 is B or C, and the same for 12. It really doesn't matter as long as you get that value A correct. Okay, so substituting values in to find, so A squared is going to be 5 squared plus 12 squared minus 2 times 5 times 12 times cos 43. Now, I would suggest as well, again, you can put this whole thing into your calculator. Make sure you put brackets after for the 2 times 5 times 12 times cos 43. And you get a value here of 81.28. Now, important to recognise, this is a value for A squared. It doesn't make sense that this side here, L, would be 81.28 when the other two sides are 5 and 12. So make sure you check for reasonableness, and this is not a reasonable answer, and the reason for that is that it's A squared. To get A, we need to square root this value, and we get 9.02 meters. Okay, so let's look at another example of this. This time we've got P, Q and R as our triangle, and again, notice we don't have an opposite pair. We've got one angle here. Opposite that, there's nothing. This is the side that we want to find. But what we do have is two sides. We've got our two sides and the angle between them, or the two sides and the included angle. And that tells us that it's going to be the cosine rule that we'll use. Okay, so now, although this is PQR, because you're given the formula in terms of A, B and C, it's a good idea with the cosine rule. It makes more sense to rename the triangle as ABC, and again, A for angle. So A, the vertex at 137 is going to be our A, and it does not matter whether it's ABC or ABC. It doesn't matter whether you go clockwise or anti-clockwise here. As long as you get the A correct, the formula will be input correctly. So redrawing the triangle with A for angle. So A at the top, and in this case I've gone ABC, I've gone clockwise. Does not matter, as long as A is correct. So we are finding the side opposite A, which will be lowercase a. So A squared is equal to B squared plus C squared minus 2BC cos A. Substitute in our values, and we can either jump from here straight to our answer for A squared, and sometimes it's a good idea, because notice in this, because it's an obtuse angle, cos 137 gives a negative value. Now these two negatives are going to make a positive, so if you put the whole thing into the calculator all at once, it should, as long as you put your brackets around here, do this for you. If you don't, if you're going to do it in stages like this interim line of working, you must be careful with these two negatives, because that's going to become a positive. So we get 455.09 plus 312.137. It's fine to go straight from this line down to A squared equals 767.227, and in a lot of cases it'll avoid, if the calculator will do the work for you, as long as you put brackets in your working in the calculator, it should automatically deal with your negatives. So A squared is 767, so square root of that to get A, which is 27.7 meters. Okay, so that's using the cosine rule to find a side. So now we need to use the cosine rule to find an angle, and this is rearranging the formula so that we have it as cos A. Now you don't have to rearrange that, it's given to you. on the formula sheet already rearranged, so you get your two versions of the cosine rule. So again, you've got your A, B and C. Your capital A is your angle, because that's what you need to find, and your A, B and C, lowercase a, b and c are all your sides. Now again, it's always about that angle at A. That is your A, which means your side opposite is your lowercase a, and that's what you should always aim for when you're using the cosine rule to find an angle or a side. Again, this is given on the formula sheet. Now, using the cosine rule to find an angle, this is where you're given no angles at all, but you are given all three sides. So this tells us it needs to be the cosine rule. To be able to use the sine rule to find an angle, you would have to have at least one angle there so that you have an opposite pair in situ. So in this case, we don't. So it's all three sides, and we need to find this angle at A. So this one here, although it's not labelled ABC, the angle is A, which means opposite that is going to be our lowercase a. And it's important to identify A, B and C. Okay, so A, opposite that is our lowercase a. B and C can be interchangeable, it doesn't matter, but the A and the side opposite are very, very important to put in the correct place. So setting down our formula and then putting our values in. So 9 squared plus 16 squared minus 11 squared over 2 times 9 times 16. Again, if you have a scientific calculator with a fraction button, put the whole thing in to get your answer. If you don't, then you could still do that all in one go. Just put bracket 9 squared plus 16 squared minus 11 squared, close bracket, and then divided by bracket 2 times 9 times 16, close bracket. You've just got to be very careful when you're using the calculator that you're inputting the values in correctly. If you have the actual fraction button, then it's very easy to do this. Okay, so calculating cos A, we get a value of 0.75, and again it's a cosine of the angle, not the angle, so we have to do our inverse cos or our shift cos to find the angle, and that gives us an angle of 41.4 degrees. Now, for this next example, again, we've been given a triangle, we've been given all three sides, and we're told to calculate the biggest angle in the triangle. Now, the size of an angle in a triangle corresponds to the sides opposite. So the smallest angle in the triangle is going to be opposite the smallest side in the triangle. So in this triangle, the smallest angle will be this angle opposite 13 centimetres. And the biggest angle will be opposite the biggest side, which is 26 centimetres. So it's important to recognise that, because when we're asked to calculate the biggest angle, we need to identify where that's going to be, and it's going to be opposite this 26 centimetres, which means our vertex at A is going to be opposite 26, which means 26 is going to be our lowercase a. Okay, so A and A, and then B and C can be interchangeable, it doesn't matter. So setting down our formula, substituting the values, we get 15 squared plus 13 squared minus 26 squared all over 2 times 15 times 13. Calculating that, it gives us a value. Now it's a negative value, that actually tells me it's going to be an obtuse angle, that negative, but for cosine we can have that negative. So use shift cos, negative 0.723, and we get 136.3 degrees.